Hello everyone, welcome to listen my project presentation video. In this video, there are three parts. The first part is what is my topic about. The second part is what do I want to research on this topic. And the last part is how can I realize it. Before we go into these three parts, let's first see some background knowledge. Three primary colors, which is red, green, and blue. With three primary colors, we can create any colors we want if we mix them with different ratio. In my project, I will use this principle to save the number of LEDs. For example, if I want to create the white color, all I need to do is just mix red, blue, and green color LEDs together, and then we can get the white color. And the second knowledge is PWM dimming or digital dimming. There is an important parameters of PWM dimming, which is called duty cycle or duty ratio. It is equals to T on divided by Tx. T on means the time when LED is on. Ts means the cycle of PWM dimming. In my project, I will use this principle to save energy. For example, if I want to save 10% energy, all I need to do is just make T on is 19% of Ts, then we can save about 10% energy. Okay, after you know this background knowledge, you can understand my project more easily. Okay, let's go into the first part. What is my topic about? In my project, I want to build an intelligent lighting control system. Mm, Intelligent lighting means technology designed for energy efficiency, which may include high efficiency fixtures and automatic controls depend based on occupancy or daylight availability. As you can see, I showed a picture of my mini system here. Mm, In the system, I have a main controller, which is STC 9HC52 single chip microcomputer, and I have many sensors here mm, to collect environmental information, and I have a LED arrays module here and a drive circuit. And what's more, to realize communication between devices, I have communication modules, and I have a displayer module too. Here I use LCD 1602 liquid crystal displayer, and the whole system will do the will do four jobs, which is collecting the information, processing the information, and calculate the tilde ratio of PWM wave and changing the brightness of LED. Okay, after this part, I think you know what is my topic about. In the work, I want to build an intelligent system which can control the brightness of LED, and this system can save energy for us. Okay, let's go into the second part. Why I want to research on this topic, as you know, there is a shortage of resource, and the resource of the earth is limited. Therefore, we need to save energy, and every year about 20% energy is used for lighting. It is a very huge number of energy, and even if I can only save 1% of this energy, it is still a huge number of energy. Therefore, to save energy, people start to seek for a new efficiency device for lighting. Then LED comes out. That's why I use LED as my lighting device in my project. And if we can control the LED with a good control plans, we can save about 20% system cost. Therefore, we need to research a new intelligent lighting control system. Okay, after this part, I think you know why I want to research on this topic, because it can save huge energy for us. It's valuable and useful for our society. Okay, let's go into the last part. How to realize it. The system will do four jobs. The first job is collecting the information by sensors. Here I use some sensors like 1AB20. This sensor can get temperature information for us, and it is easy to control. And then I have a sensor, I have a clock chip named DS1302 to calculate the time. This chip can work automatically once the microcomputer controls it. With this chip, we can get the information of time. And the second job is processing the information collected by these sensors. Here I use a single chip microcomputer named STC89C52 to process this information. The microcomputer will receive this information and then it will process this information with a formula, and this formula will calculate the tilted ratio of PWM wave for us, and then the microcomputer generate the PWM wave of with special tilted ratio value. Then it can output then the microcomputer will output the state of system to this displayer module or communication module. Maybe we will use Wi-Fi as our communication module, and LCD 1602 liquid crystal displayer as our player module. And the second job is calculate the tilted ratio of PWM wave. Here we will use a formula. This formula is the relationships between brightness and information created by system. Says this information it can be B is the function of T1, I, T2, and O. Here B means brightness of LED, T1 means the environment temperature, I means illumination, T2 means the real time, O means other factors, and this formula is the most important work of this project. Unfortunately, I haven't worked it out, so I need to work harder, but I have confidence that I can work it out. Okay, the last job of the computer, the last job of the microcomputer is to change the brightness of LED, which can save energy for us. Here we use a PT4115 to build a drive circuit because the drive power of microcomputer is very low. Therefore, we need a drive circuit. As you can see, we input PWM wave in one of PT4115 pins, and we connect LED arrays to one of its pins. Here, if we want to change the brightness of LED, all we need to do is change the tilted ratio of PWM wave here, and we use different colors LED arrays here, which is my video. I think you know what is I am working on, and if you have any questions, please let me know, and thanks for your time.